Hey everybody! The purpose of this video is to get you some solutions to this goodness of fit quiz about pulling the blocks out of the bag. So we got some blue and some green blocks in a bag. We're pulling them out. Try to figure out if what we saw in class is roughly consistent with what we should have seen, which is theoretically down here. Let's look real quick. 1/2 is 0.5. That's roughly half the observations. That's the biggest. Let's see, this might be a little bit low. You got 96 and 88. That's about 170, 180. 210. That might be a little bit low. And then this should be less likely than this, although that's more than that. Although that's pretty close. You know what? This is why we don't do it like I'm describing right now. We actually crunch these things using statistics, using inferential statistics, using hypothesis tests. So anyway. Here's a template for us to plug away. We are definitely testing a proportion P. That's for sure, right? And the idea is we're actually testing 4 of them. Go back to your template. We're testing 4 different ones. This one, this one, this one, and that one. The 4 different proportions, which hopefully add up to 100%. We'll check that in a minute. And those 4 different proportions giving us the results of this experiment. So defining the variables, it's going to be each percentage represented in the experiment. Yeah, and you can say that a bunch of different ways. You basically somehow indicate you're studying, testing each of the percentages that are indicated down there. Now, the null hypothesis is that the percentage of all blue is going to be, what is that down there? That is, I forget what it is already. It's 1/6. Let's write these out. That's 1/6. The percentage of 3 blue, 1 green is 1/2. Oh, look at that. That was clever. The percentage of 2 each is 0.3. And the percentage of 1 blue, 3 green is whatever's left, and I'm saying that's 1/30. So those are your percentages that we should be seeing, assuming everything's behaving. If we're not seeing that, that means at least 1 percentage is not what it should be. And that's the, oops, it doesn't recognize that. Percentage is not what it should be. So there you go. So the idea now is which one of these can we support with our test statistic and p-value down here. We'll get to that momentarily. Excuse my voice today. I'm fighting a cold and I sound like a frog, more so than usual. Type 1 error would be saying a proportion is not following the assumed distribution, but it is. That means we flagged it for something being wrong. Remember those comments I was making earlier when I made a comment like, I said, well, this should be 1/2 and this is less than 1/2. That looks off. Suppose at the end of the day, if we get to the end of our test and we make the statement that, yes, something is off, but it's not, that would be a type 1 error, false positive. Type 2 error would be essentially saying the opposite of that, which is saying all the proportions are behaving as they should from the assumed distribution, but at least 1 isn't. There you go. Which would be worse in your opinion, and why? I'm going to go with type 2 on this one from a pedagogical standpoint. Here's why. If I say something's off, that's going to make me go back and look at it again, and I probably catch my error. But if I assume something is right, but it's actually not, I'm going to keep generating strange results. Although I guess that could flag me to go back and look at it again. So, in my opinion, I'd rather not keep operating on an incorrect assumption. I don't like that. Sometimes I do it inadvertently in class, but I don't like to intentionally, or at least predictably, do it. I like to be able to fend that off. Alright, so we're doing a chi-square. This is the beauty of a chi-square. We now need a test statistic, which is going to be chi-square equals something. and we need a p-value. Okay, so let's get both of those. I don't actually have TI installed, but I can code it really. I can actually code your program fairly quickly on the computer here. Let me just minimize all this stuff. Here we go. All right, so let's go in here, stat edit. Now I need the numbers from the observations that we saw, which were 96, 156, 88, 30. 96, 156, 88, 30. 96, 156, 88, and 30. Now, like I said, I don't have the program on here, but I am going to, I don't know why I was repeating this, they're sitting right here. 1/6, I'm going to do a little cheater move here. 1/6, 0.5, 0.3, and 1 divided by 30. All right. So those are the percentages. That's 0.8. Yeah, they add up to 100%. We're good to go. What I'm going to do now is I'm going to do a little bit of a command in here. This is what I actually have coded into your program. If you look at the code of your program, I'm going to take each of these percentages and multiply it by the sum of this one. So what I'm going to do is I'm going to type this as L3 times, then I have to go to the list menu, find the math, times the sum of list 1. When I press enter, boom, it's going to fill all those in. So in other words, we should have seen 185 occurrences of getting through blue 1. We saw 156. So like we said, we were a little bit low on that one. The question is it so low to be flagged as unusual? We should have seen 61. We saw 96. We saw too many of those. We should have seen 111 of these. We saw 88. We saw too few of those. And then we saw, again, a little bit too few, or excuse me, a little too many of the 3 green 1 blue situation. So the question then is, are these off in such a way that we should flag the test as being broken, or if there's some kind of sampling issue going on? I don't know. Let's find out. Let's find out. So now what I have to do is I need to actually construct my chi-square value, which means I have to build the whole statistic from scratch, which is super fun, actually. L1 minus L2 squared divided by L2. Ba-boom. Okay, so these, now check this out. This is pretty cool, actually. I'm pretty stoked about this. My gut was off in the wrong place. So according to this, the 185, where we actually got 156, is the least offensive of the results. The most offensive is this one down here. And I guess multiplicatively that makes sense. We got 2.5 times too many of those compared to this, which is less than 20% too many. Okay, that's cool. Okay, so that right there is going to be our test statistics. So I'm going to kick out of here for just a second. Okay, go back to the list, go to the math, and sum up L3. L3. Ba-boom. Okay, 53.7 is our test statistic. 53.7. Now, remember that's not standard deviations. That's just it's a I'm going to call it a unitless measure of agreement. 0 is the minimum, and it goes off forever out into the tail of the tail of the chi-square curve. What I'd like to know now, and I'm going to ignore the TI and go to Excel instead, and actually use the grapher that we used in class to do this, because it'll give me the curve. We have 4 categories, just like we did in class when we were looking at the ADA exam. So the curve looks like this, and you can tell if our test statistic is 53.7, oh wow, it's way over here. So if we put in 53.7 for a test statistic, it's going to tell me there's your p-value. You are totally justified calling that 0. It is essentially 0. So you got a p-value, big P, of about 0. Whoops. I'll make it big because I know we barely emphasize that quite a bit in this class. Your p-value is 0. More correctly, it's 1 times 10 to the negative 11th. So it does definitely appear. It appears that at least one of the percentages is not what it should be. There you go. It appears that at least one of those percentages is not what it should be. Boom. We could be wrong with the type 1.
But I, for one, would want to go back and look at that experiment, run a few more times to see if I could figure out what was going on. That's pretty cool, actually. That's pretty cool. So you could also run what's called a post-hoc test. I'm going to leave that be for other folks in other stat classes if you take more stat classes. Not important right now, but the key is that something's up, most likely, unless we were wrong. So there you go. I hope that was helpful, and we'll see you in class.